So like I said, this is kind of a review from before. So if you guys look at x squared plus 6x plus 8, right? If you were to, Damien, can you stop? Yeah, if you were to factor this, remember, you're looking at two numbers that multiply to 8 and add to 6. Any thoughts on those two numbers? As a little recap, yeah. 2 and 4, absolutely. So if my pen starts working here, this would just be, right, two numbers that multiply to 8 and add to 6 is 2 and 4. So basically, right, we've got x plus 2, x plus 4, and we know it's the opposite, right? So basically, you'd have those 2 points is x plus 2 equals 0, so x equals negative 2 when you bring the 2 across, and x plus 4 equals 0, so you bring the little 4 across. The idea is that it's the opposite, right? When you see plus 4, it's minus 4, plus 2, it's minus 2. So those are your two little x-intercepts. So this one factor's nice. What I want to do is I'm going to show you how to do this second method. It's going to be a bit more complicated because you have to complete the square, and I know it's not fun. But let's pretend that wasn't factorable. This is a way of doing this if it's not factorable. So basically, let's look at the vertex here, right? We know that the vertex is between these two x-intercepts. So you go negative 2 plus negative 4 divided by 2, or you just know it's between the two of them, right? So that's got to be negative 3. And then you just put negative 3 into the equation, right? So what is the y of the vertex? You just put it in. You're going to get y equals negative 3 plus 2, right? And negative 3 plus 4. And so your y value is negative 1 times 1, which is negative 1. So our vertex is negative 3, negative 1. All right, we get that just basically by finding the middle of the x-intercept, so it's got to be negative 3, and then you put it into your equation, and you'll get negative 1. I think I did that all right. Any questions so far? I know we haven't really done the completing the square bit yet, but that's the idea right there. Oh, for sure you can, buddy. Yeah, I'm gonna pause the recording, but yeah. All right, so this is a little reminder on completing the square. So remember, x squared plus 6x plus 8. I'm going to rewrite that equation down. Remember, to complete the square, you take that middle number, which is 6, and divide it by 2 to get 3, and then square it to get 9. Do you remember that kind of? And it's kind of when you do like the y equals x squared plus 6x plus 9 minus 9. We're doing that. That was kind of like when we added 9, because this, right, is x plus 3 squared, because it's 3 times 3 is 9 and 3 plus 3 is 6. So you get that, and then negative 9 plus 8 is just negative 1. And if you look from that, right, remember x always lies, so you'd have your vertex is negative 3, negative 1, and right from there, right, the opposite and there, and that's what we had before, right? So it all works out good. So I just want to show you again, you can complete the square even when something's not factorable, right? You can always do this. But let's see, can we put the x-intercepts from this form? Because you can do that, which we can. You can find the x-intercepts even if they're like ugly decimals or things like that. So let me show you that. This is those same x-intercepts right here, negative 2 and negative 4. So here's how we do that. We're solving for the x-intercepts. All you do, right, x-intercepts are y is equal to 0. Sorry, I walked away from the mic. People aren't going to really know what I was saying there earlier that missed class today. But we are saying set this equals to 0, y equals to 0. So it's always like this. Watch how this kind of works out. Let's use black here. So 0 equals x plus 3 squared minus 1. Basically, you're solving for x, right? So following Sam Deb first, right? And you basically would go ahead and do all your opposite order of operations. So moving the 1 across, you're going to get positive 1 instead of minus 1, right? So 1 equals x plus 3 squared. Here's an interesting piece, though. what would be the next step that I would do to get x here by itself? What's the next thing I should do to both sides? Yeah, Tucker? Well, you mean the 3 maybe? It's in the brackets, so we can't deal with that first, right? So remember, SAM-DEB is for solving. Brackets are the very last thing we want to do, right? So first is E for exponents. Yeah. You need to subtract what, buddy? No problem. So when we look at this here, right, trying to get x by itself, we did subtraction and addition already, right? We moved the 1 across, we got rid of that. There's no multiplication or division. But if we had that, we do that next. Now we do the exponent. Yeah, Khalid. Okay. The opposite of square is square root. The only thing is that when you take the square root of something, it can be positive or negative. If that makes sense, right here, over here, 9 equals x squared. When I'm thinking about this, right, like what value of x works, it could be positive 3 or it could be negative 3, right? Because negative 3 squared is still 9. So whenever you take the square root, don't forget to say there could be a positive or a negative. It could be 2 options. This is just an idea when you take that. It's not part of the question. So there's 2 answers here. The square root of 1 is just 1. Right? That's pretty easy. But basically, you're going to get the positive 1 equals, we don't need the brackets anymore, we can just write x plus 3, and you're going to get negative 1, right? Negative square root of 1 equals x plus 3. And when you solve those, right, bring the 3 across, it's 1 minus 3 equals x, so x equals to negative 4. And here, when you bring that 3 across, it's negative 1 minus 3. Wait, that should have been a positive. Sorry, guys, I screwed that up. That's minus 2. That was a positive. I don't know. I think I was thinking about this one already. This one is that x equals minus 4. So it's not that much trickier. The only thing you have to remember is that, like, there should be 2 answers, right? That's the whole idea here. But that's how you get 2 answers, because the new factor, right, was negative 2 and negative 4. All right, let's do that a couple more times here. So obviously, factoring is easier than completing the square. I think you'd probably agree with me on that. So is what I'm still writing with? Yeah, okay, I'm gonna pause this first. All right, so let's try that a couple more times. So when you're doing with something like this, let's just do the first one here, right? Completing the square. Rational solutions mean ones that are fractions. These are nice numbers, and so it's kind of like the one we just did, right? So when you're doing this, again, cut 12 in half, that's negative 6, and square it. That will be 36, so minus 12x plus 36 minus 36 plus 20, that's not a 20. This is, right, this part can be factored to x minus 6 squared, and then this becomes minus 16. And so now you can solve this pretty easy, right? Move your 16 over, right? This is completing the square done, but now we can solve it. So 16 equals x minus 6 squared. Now you take your square root, right? But remember, plus or minus square root 16 every time. What's the square root of 16? So you got a pulse here. We good? Yeah, 4. Thanks, guys. So it's going to be 2 answers, right? It's going to be positive 4 equals x minus 6 and negative 4 equals x minus 6. When you bring that 6 over, you're going to get 4 plus 6, so 10 is one answer. And this is negative 4 plus 6, so that's going to be 2. So That's how you can get an answer for a rational solution. These could have been solved because they were rational. They could have been solved by factoring. And I'll be honest, factoring is easier. But when I show you the next example, they're irrational. Irrational is like decimals are replete forever, right? Like square root 2. It's a decimal that's not a nice number, or pi. You could never factor and get those answers. And so let's look at a couple and how that looks when there's ones that are irrational. I see a couple people still writing, so I'm just going to keep it chill for a sec. Sounds good, buddy. Remember, it's always online too, right, bud? It's always online. Hello? Yes? Did I forget attendance? Probably. Can you hear me? Can you guys hear me? So, irrational solutions. So when you're looking at ones here, let's do B, I guess, whatever. Thinking about this here, right? Like, what two numbers, if you tried to factor this, multiply to -8 and add, I feel like this is possible, but let's see. -4 times +2, right? But yeah, no, there's no way that we can come up with two that work for that, right? Like 4 and 2 are what you want to use, but this would have to be -4 times -2, and that's not -8. So basically, it's not factorable, we would see. So let's see if we can solve this one by completing the square. We can come back to this one as well, too. But this one here, just so you remember, this is x squared minus 6x. Remember, half of 6, so you do -6 divided by 2 is -3. You square that, that's 9, right? So plus 9 minus 9. And you're going to get x plus 3 squared minus 17 equals to 0, right? And now you can solve that. So bring the 17 over. So you're going to get x plus 3 squared equals 17. Right? When you move the -17 across, take the square root. Remember, don't forget your little plus or minus. But you see now, like square root of 17 isn't nice, right? It's ugly. So you're going to have decimals. And so remember, I actually don't know what the square root of 17 is as a decimal, so I'm going to have somebody maybe, let's see, I think I have a calculator here. Square root of 17 is 4.12, right? So you're going to have positive 4.12, and then you're going to have x plus 3 equals negative 4.12. So move the 3 across, 4.12 minus 3. Your first answer is 1.12. I think, right? No, actually, maybe that's not right. Oh yeah, 1 point. I don't know why I second guess myself. And then this one is x equals negative 4.12 minus 3, which is negative 7.12. So obviously, those being the answers, you could never have factored that, right? Not possible. So this is a way of solving something when you can't factor it. You complete the square, get it in vertex form, and set it equals to 0. Sorry. Any questions on that so far? Completing the square I know is not fun, but it's definitely clearly a necessary skill now because you can solve stuff when you couldn't factor. All right. I see a couple more writing in a pause. So basically, Notice for each of these equations, there were only, we didn't do the first one, but there was irrational solutions, meaning they're not nice fractions. This could not have been solved by factoring. So irrational and cannot have been solved by factoring is the key there. All right, I want to show you one more where it's a non-real solution, which means there's imaginary solutions, which is the dumbest thing ever, but basically this means that they don't exist. And so try this one here, right? If we tried x squared minus 6x plus 10, when we go to do this, like obviously you try to factor and you're like, okay, what times what equals 10, what plus what equals negative 6. You could guess all day long and there's not going to be an answer there, right? 5 times 2 is 10, but there's no way, right? 10 times 1, like it just doesn't happen. And so if you complete the square, right, half of 6 is 3, square that is 9. You're going to notice this, right? This part, again, is x minus 3 squared, and negative 9 plus 10 is plus 1. So watch what happens when you go to solve this, right? You move the 1 across, and that's negative 1 now, right? But then when you go ahead and take the square root, right, plus or minus the square root of negative 1, if you try the square root of negative 1 in your calculator, that is an error, right? It doesn't exist. So not all quadratics have solutions. This means there is no solutions. You're getting an error here, right? There's a square root of a negative. So anytime you have to do that, you know that it's no bueno. All right.